Welcome back to Samsung Developers. I'm Vincent, one of the developers here at Samsung. Creating richer and livelier applications has become easier with Samsung's Visual View SDK. We will get to know more of the Visual View SDK and at the end, create a Visual View sample application. Visual View allows you to easily add animations and visual effects to your own application. It can support up to 85 animations that adds a lively texture to the application itself. With Visual View, your applications can denote geometry, lighting, and projection methods. Visual View is based on OpenGL ES 2.0, an essence of OpenGL specification for embedded devices, which allows application of property values of 2-dimensional and 3-dimensional for easy animation. The Visual View provides the following features: provide texture depth and a bevel effect using perspective view. More refined adjustments can be applied to view, utilizing advanced geometry. Basic animation uses basic property values like position, scaling, and rotation. With this, you can set from and to values to specify transformation and movement. Keyframe animation lets you indicate property values for each keyframe and apply changes in animation. You can also make use of transition animation for scene page transitions. With this, you can apply almost 40 transition effects to your animation. Visual View also provides sprite animation, wherein you can use a library of sprite images and texture atlas to get the animation going. And lastly, Animation Set lets you have a container for a group of different animations to run simultaneously. Not all devices and Android APIs can support Visual View. Here are the restrictions. Only Android 1.6, Donut, or above support Visual View. All devices that support OpenGL ES 2.0 can also support Visual View. Performance issues occur when using a lot of slides, so be sure to check your device. As an example, the Note 3 is guaranteed to be able to support up to 500 slides. Before we start creating a sample application for Visual View SDK, please prepare the following: Eclipse IDE with ADT plugin, components of Visual View SDK. You can download these from developer.samsung.com, a Samsung device that supports Visual View, and if you don't have a device, you can go to the remote test lab to test your application out. Let's start creating our sample application. First, open up your Eclipse IDE. Let's wait for it to load. We're going to make a bouncing ball application using Visual View. We will create an image of a ball that makes it move around the screen and then bounce it off to a different direction as it reaches the edge. So, let's go ahead and create a new Android application project and name it Bouncing Ball. Finish the creation of the application, then copy the components of Visual View SDK to the library folder of the application. Next, go to the manifest file and include the following permission to avoid security exception. First, we initialize the visual view by creating an instance of SV, then use sv.initialize inside the try-catch block. After that, we create the SVGL surface instance for rendering. Now, to do that, we create a private variable mSurface, initialize it to a new SVGL surface, then explicitly set the activity content view using setContentView with mSurface as the argument. We also need to set the boundaries where our ball can freely move. Let's set it up to the whole dimension of our screen. We create a variable window size, then instantiate it as a point. We use this.getWindowManager and getDefaultDisplay.getSize function and key in window size as its argument. Using windowSize.x and windowSize.y, we now have the data needed for creating the area where the ball will animate. Visual View uses SVSlide. SVSlide is somewhat similar to the Android view where you can attach animations. One approach in using Visual View is to create a set of slide instances, then apply the desired animations to it. What we are going to do in this sample application is to create two SVSlide instances. One would be the SVSlide for the background, and the other is the SVSlide for the ball. First, let's set up the background. We create an SVSlide variable, mbgSlide, and instantiate it. Now, SVSlide needs the following parameters. Parent slide, set this to null. Float value for the slide's X region and another float value for the Y region. Set it both to 0.0f. Next is the width and height. We set them both using windowSize.x and windowSize.y. Lastly, we set the color using svColor and input float values for it. After creating, we then add this to the SVGL surface by using mSurface.addSlide and the mbgSlide as its argument. After creating a background, let's go and construct another SVSlide. This other SVSlide will act as a sub-slide to our background slide, mbgSlide. It will also contain the image of the ball and the one that will be animated in this application. So we create an svSlide variable mSubSlide, then instantiate and complete the required parameters. To set up the image to a slide, we first decode the bitmap resource. Then create an instance of svImage. Add the created bitmap to it, and add the svImage instance to the slide by using mSubSlide.setImage function. To add the subslide mSubSlide to the mbg slide, we use the function addSubSlide. Now that we have finished setting up the slides, we can now start with the animation. For this, we use implicit animation. We iterate and change the position of our mSubSlide over time. To make it a continuous animation, we will use a runnable object and use a handler class to schedule it. Let's input a delay for the runnable. We use mSubSlide.setPosition to set the new position of our ball for every run. The parameters needed an SV point, or the position of the center of the slide, and the duration of the implicit animation in milliseconds. Since we'll be iterating, let's create variables x and y that will represent the next position for the ball. The last thing we need to do is the mechanism to determine the direction of the ball. First, we detect the current position of the ball, then check if the position exceeds the edge of the screen. Then lastly, set the direction of the X and Y coordinates of the ball with respect to the return flags of screen bound detection. Okay, this one's done. Here is the application that we created. We can see that the image of the ball we imported earlier just moves around the screen, bouncing to different directions as it reaches the edge. This runnable we created makes the animation run in a loop. That's it. Let's go over the things we talked about in this session. Visual View SDK allows you to add various kinds of animations to your applications. Learning how to use them can make your application livelier and richer in texture. There are different types of animations. Knowing them well can help you decide what kind of animation will suit your need. Don't forget to add needed components into your library folder, as well as the needed permission in your manifest file. And lastly, keep in mind the restrictions, may it be the Android API or in accordance to performance issues. That's it for Visual View. We hope this tutorial helped. For inquiries, please post your questions on the official forum at developer.samsung.com. Thanks for watching.